Welcome. Let us continue the lesson on assumptions in hypothesis testing for a single mean, the null and the alternative hypothesis. In this, we consider now the part 3 that deals with the statistical hypothesis and the various steps in carrying out testing and types of errors. Leading objectives: we will be able to describe the steps in carrying out testing of hypothesis, to understand the two types of errors in the process of testing of hypothesis, to understand that these errors cannot be completely avoided, but rather tried to be reduced, to understand the effect of both errors. We make the following statements, which we have already covered. Researchers do not try to prove a hypothesis. Instead, they gather evidence to support or not to support the hypothesis. Hypotheses are formulated based on theory or knowledge gained from the literature. A measurable characteristic of the population is considered and it is assumed to follow a known distribution, usually normal. Most null hypotheses are set up to be rejected. Rejecting the null hypothesis is based only at a probability level, that is according to a probability value that has already been set. No decision on the veracity of the hypothesis is made. It may appear that the result may be practically significant, but we need the statistical significance. Now, we state the steps in carrying out the testing. First step, state the null hypothesis. Second step, state the alternative hypothesis. Third step, select a statistic and a level of significance. 4. Decide the critical region. 5. Make a decision to reject or retain the null hypothesis. From our previous presentation, we considered a hypothesis as null if it is a standard result or natural result, etc. At the same time, it is falsifiable. A statement in contrast with the null is called alternate one. This is usually a deviation from the natural result, and this is what the analyst wanted to prove. Steps 1 and 2. We denote a null hypothesis by capital H or H suffix 0 and the alternate hypothesis by K or capital H suffix 1. The alternate hypothesis must specify a direction. For instance, if H is mu equal to 100, then the alternate K could be mu not equal to 100 or any one of mu greater than 100 or mu less than 100. The first type of K is called bidirectional or two-tailed test, and the other two are called one-sided or one-tailed test. We already stated that for a large sample taken from a population with mean mu and standard deviation sigma, the sampling distribution of the mean approaches a normal distribution with the mean mu and standard deviation of sigma divided by square root of n. Standard deviation of a sampling distribution is also called standard error. In other words, the variable z x bar minus mu divided by the ratio sigma by root n has normal with mean 0 and standard deviation 1. In the case of sigma is unknown, we use square root of n divided by n minus 1 times small s as the standard error. popularly known as S dot E dot. Step 3a. Hence, one has to select an appropriate variable that has normal distribution. We then calculate a ratio. X bar minus mu 0, the mu 0 is the value proposed by the hypothesis. In the denominator, we have standard error. This is also called test statistic, which has normal distribution with mean 0 and standard deviation 1. Step 3b. Fix a value that specifies a probability in case we reject the null hypothesis when it is true. The value is also called level of significance. We usually fix it at 5% or 0.05, so that in 5% of cases we may falsely reject the null hypothesis. Step 4. The critical region is the tail area within which, if the test statistics takes a value, we make the decision of rejecting the null hypothesis. The alternate hypothesis indicates the rejection region. The reason for calling tail tests will now be explained. We have given here a plot, a normal curve plot. You can see that the area under the curve between minus 1.96 and plus 1.96 is highlighted. This area has the value 0.95. An alternate hypothesis equal to can be rejected if we reach beyond these limits. We have given two plots. In each plot, some area is highlighted. That area is the probability value of accepting. The area is not shaded. You can see the white shade, that is the area we reject when we get a value in that region. So, for the first diagram, there is 1.65 is up to that point is shaded. In the second diagram, the area from minus 1.65 is shaded. So, the unshaded area is the rejection region. If the null hypothesis is not true, then the limit for critical region can be taken up to the limit minus 1.65 for the less than type k and plus 1.65 and above for the greater than type k. Types of errors. We already told that we may make a mistake in taking decision for accepting or rejecting. The following table gives the 4 possibilities when any one of the decision reject or accept is made with the actual status true or false of null hypothesis. Please read the table from left side to right side. Reject H when the null hypothesis is true, that is the first box. Second box, reject H when the null hypothesis is false. In both cases, we are making a decision. In the first case, that is rejecting H when null hypothesis is true, is called type 1 error. For this, the probability is alpha. When you reject H when the null hypothesis is false, it is a correct decision. So, we are taking correct decision and two cases: reject H when it is false, do not reject H when it is correct. But we are making error when we are rejecting H when it is true, accepting it when it is false. The first one is type 1 error, second one is type 2 error. For the first type 1 error, the probability of committing the error is alpha. For committing type 2 error, the probability is beta. Type 1 error is committed if you reject the null hypothesis when it is true. Type 2 error is committed if you accept the null hypothesis when it is false. Probability of committing type 1 error is indicated by alpha. Probability of committing type 2 error is indicated by beta. The power of test is defined as 1 minus beta. Increasing the statistical power 1 minus beta of a test directly decrease the risk of making type 2 error. Type 1 and type 2 errors influence each other. That is because the significance level, the type 1 error rate affects the statistical power, which is inversely related to the type 2 error rate. You can see this diagram. The first curve left side is the normal curve for null hypothesis. The second curve is the normal curve for hypothesis, alternate hypothesis. You can see the shaded region. I have put a vertical line with red color. The right side of the vertical line under the curve for normal distribution proposed by the null hypothesis is called alpha. You can see the indication alpha. Left side is called beta. So, you can see that when you are increasing it, you are moving the vertical line right side. In that case, beta increases. If you move the vertical line left side, beta decreases, but alpha increases. So, this is the fundamental aspect of the type 1 and type 2 error. The above graph brings out the relationship between the probabilities of type 1 and type 2 error. If one is decreased, the other increases and vice versa. Which error actually affects the decision making? The type 1 error is worse, as we reject a standard or normal result, and hence the existing theory is rejected. Some new theory has to be pursued. However, both errors affect the decision making depending on the nature of study. We will summarize what we have learned in this lesson. We defined the term statistically significant. We distinguished between statistical significance and practical significance. Introduced the concepts of population, mean, parameter and statistic. Described the steps in carrying out the testing procedure. Two types of errors in making decision are explained. Now, we are coming to the end of this lesson, and we have given you very important fundamental facts. We hope you are benefited. Please note that these ideas and facts will be necessary for doing research in psychology using statistics. Thank you.